So in our last video, we talked about data centers and why they're important and why our design should be supporting multiple data centers. And but this will not be enough to support millions of users. So we still need to do some other modifications. To further scale our system, we need to decouple different components of the system so that they can be scaled independently. A messaging queue is a key strategy employed by many real-world distributed systems to solve this problem, especially if we have tasks that need to be processed asynchronously, like some sort of background jobs or things of that nature. So what is a message queue? A message queue is a durable component stored in memory that supports asynchronous communication. It serves as a buffer and distributes asynchronous requests. The basic architecture of a message queue is simple. Input services, called producers or publishers, create messages and publish them into the message queue. Other services or other servers, called consumers or subscribers, connect to the queue. They subscribe to the queue, and they usually perform some predefined tasks according to the parameters or instructions that's passed by the message. So we have a very simple diagram that's showing this relationship here. Decoupling makes the message queue preferred architecture for building a scalable and reliable application. With a message queue, the producer can post a message to the queue when the consumer is unavailable to process it. When the consumer comes online, it can read messages from the queue even when the producer is unavailable. So we create a synchronous communication between the producer and the consumer. A sample use case would be some photo customization application. So let's consider that. So let's imagine we have some customization tests such as cropping, sharpening, blurring, and they take time to complete. So let's imagine web servers publish photo processing jobs to the message queue. Photo processing workers will pick up those jobs from the message queue and asynchronously perform photo customization tasks according to the parameters that are defined in the messages. The producer and the consumer can be scaled independently. When the size of the queue becomes large, more workers can be added to reduce the processing time, obviously. If the queue is empty most of the time, again, if the queue is empty most of the time, when we don't need that many workers, we can reduce the number of the workers, number of consumers. So, when we are working with a small website, as we initially had at the beginning, a single server setup, which runs one or maybe a few servers. Logging metrics automation, they're nice to have, but they is not really necessary, and they usually looked over by companies that by smaller companies, smaller startups. But if you're growing the business, if you're growing our system, we should investigate into those tools. So let's start with logging. Monitoring error logs is important because it helps identify errors and problems in the system, and trust me, we will have very interesting errors that we thought we will never get. By implementing logging, we can monitor error logs at per server level or use tools to aggregate them into a centralized service for easy search and viewing. Metrics is another aspect of these tool stack. Collecting different types of metrics will help us to gain business insights and understand the health of the status of our system. Especially business insight part could be quite useful in this case. Let's talk about like different kind of metrics that we can collect. We can collect host level metrics, CPU, memory, disk input, output, and things of that nature. We can aggregate those metrics into a aggregated metrics server, possibly. For example, we can aggregate the performance metrics of the entire database tier to cache tier to one certain log logging server, or sorry, metrics server. And maybe the most important part is obviously like the business metrics, right? For example, daily active users, retention, revenue. These are the metrics that will enable us to grow our business. Since we're on the topic, let's talk about automation as well. When a system gets big and complex, we need to build or leverage automation tools to improve productivity. That becomes a huge issue in large-scale companies, right? Because you have thousands of engineers, and if every engineer like spend their time on a repetitive task, half an hour on a repetitive task on a daily basis, that's 100 times 30, that's about 30,000 hours in a day, right? That you're actually losing, whereas you can automate that. Some examples of that: continuous integration, automating our build, test, and deployment processes, which will further improve our engineer productivity. So after these, and after adding the message queue to the design, it's going to look something like this. Oh, sorry, not this one. So after these, after adding the logging metric and automation tools and the message queue to our system is going to look something like this. So now we include a message queue, which helps our system to make more loosely coupled, especially for asynchronous tasks. And we will also be improving our failure resiliency. And here we also have the logging, metrics, monitoring, automation, more like DevOps tools included in our system. Thanks for listening. And in the next video, we are going to talk about, we're going to go back to database actually. We're going to talk about how we can scale them, how we can scale database or the data tier. So stay tuned.